Hello, so today's purpose of the video is to compare linear versus exponential. They are very similar, okay? So we're gonna look at their similarities and their differences. So I have two different tables here, and I wanna figure out which one's linear, which one's exponential, and how to write their equations. So remember, linear is slope-intercept, y equals mx plus b, and exponential is a times b to the x. So n is our slope, b is the y-intercept. Right here, a is the y-intercept, and b is our ratio because we're multiplying. So let's look here at table 1. So look here, we look at the y values and see what's going on. I'm going from 5 to 10, so I could be adding 5. Okay, so 10 plus 5 is not 20, so that's definitely not linear. So now let's figure out what could it be multiplying by. So if you never know what it's multiplying by, you can always divide. Just make sure you take the second number first. So this is 10 divided by 5 is 2. So I am multiplying by 2. So that would mean this is exponential. Okay, so my equation for table 1 would be y equals y-intercept. Look for the zero term. I have it. It's 5 times my ratio is 2 and to the x. So that's the exponential. Now let's look at a linear example. So here I'm going from 8 to 11. If I didn't know what this was, let's say it was a very big number, I can do 11 minus 8, and that is what? 3. Let's make sure I can continue on. 11 plus 3 is 14. So since I'm adding 3, that means this is linear. So I'm going to do y equals, my pattern, my slope is 3x, and then plus b, the y-intercept, we have the zero term, it is 8. So the differences between these two is that this is multiplying by 2 starting at 5. This is starting at 8 and adding 3 every time. Okay, so example of exponential, example of linear. So now let's look at their types of graphs for linear and exponential. Okay, so right here we have two points, 0, 12, and 1, 3. And they're asking us to create a linear equation and an exponential equation that goes through both of these 2 points. Linear is pretty easy for us. We've done this. So remember, to find our slope or our rate of change, we can figure out, I like to make a little table. This is x and y. So 0, 12, and 1, 3. Okay, so remember, I can figure out my pattern by seeing what's going on each side. So this is linear. I need to be adding or subtracting. Obviously, I'm going down, so subtracting. So 3 minus 12 is what? Negative 9. And then this is 1. So put it together, negative 9 over 1. Remember, y is on top always, is negative 9. So my slope is negative 9. Did they give us the y-intercept? Yes, they did. It is 12. So y equals negative 9x plus 12. Okay, so there's our linear equation. So now we need to do the same thing for exponential. Okay, I'm gonna make another table so I can write on that one. Use a different color. So I want to make the exponential equation. Okay, so again, I'm going from a bigger number to a smaller number. So my head should already be thinking about, is this going to be a growth or decay? It is going to be the decay because I'm going down in my y values. So I need to figure out how I'm multiplying. To do that, I can do the opposite and divide. So what is 3 divided by 12? That is 1/4. Okay, so what is my ratio? 1/4. You can also put it as a decimal if you prefer. So you could do 0.25, up to you. So my equation, again, I know the y-intercept is 12. And then my ratio is 1/4. Again, you could use 0.25 to the x. So let's just look at what these look like graphed. I'm not going to draw it up here because I suck at graphing on the computer. So let's look here. Y equals negative 9x plus 12. There's our linear. And then y equals 12 times 1/4. Again, you could do the decimal to the x power. And you can see here, they both are intersecting at 1, 3. and they're both intersecting at 0, 12. So that way we do know this is correct. And you can see here I have a line that's going down and I have a curve that's going down. All right. Last one, they just want us to compare linear and exponential and then talk about, all right, a line appears to rise more quickly than the exponential at first. The exponential eventually catches up and surpasses. That just means higher than the linear. Why will an increasing exponential function always catch up with an increasing linear function? Well, let's just look at them, the two functions on Desmos. So it's 20x plus 5. So y equals 20x plus 5. And then our exponential is 5 times 2 to the x. Y equals 5 times 2 to the x. Okay, I'm going to go back to home. So right here, my equation for the linear is starting at 5, same here, starting at 5, but here I'm adding 20 every time, whereas here I'm multiplying by 2 every time. So as we can see here, if I just keep going out, what happens? Okay, I'm going to keep going out again. What happens to it? The exponential, it does eventually get higher than the line. Why is that? Think about it. Adding 20 versus multiplying by 2. Which one's going to get higher eventually quicker? Multiplying by 2. So that is why exponentials will always outrun linears eventually. Okay? So make sure you keep this in mind. Reference this video if you need extra help, and I'll talk to you guys later. Bye.